All right, this is 6.1. All right, I'm back. This is 6.1, numbers 6 through 8. Basically, these are just a few rational rules, a few radical rules, not rational rules. Basically, involving things all having the same radical. Okay, this is what can you do if you have the same radical, like they're all squared, they're all of the third, they're all of the fourth. So, for example, if you have two things, the same radical that are multiplying, you can either break them up or you can put them together. For example, these are both to the third power. 4 times 2 is 8. Just remember, it's still to the third power. Okay, that does not go away. All right. Likewise, the quotient property. If you are dividing two things with the same radical, so I can either, they're all to the n, all to the same number. I can either write it as one big one like this, or I can split it up as 1 over another. So, for example, over here, they're both to the fourth. So I rewrote it as one big one, and then did 162 divided by 2, which is 81, which I can actually take the fourth root of. Gets me down to 3. Sometimes you can take the root of it, sometimes you can't. But this is, I think we would all agree that even this one is easier to read and understand than that one. Okay? The whole point is getting it down to its simplest form so it is easier to deal with. Okay? So here we go. Let's work on 6 through 8 real fast. Let me back out, discard, scroll down. All right, here we go. Number 6. No, go back. Number 6. Okay, we have the same radical. They're both to the 6th power. And we're multiplying, so we just simply can think of it as 25 times 625, which is something huge. Give me a second. All right, that's the 6th root of 15625, 15,625. Okay, which we'll stick that in our calculator and see if it comes out. Why not? To be honest with you, the easiest way to put something with a higher radical in it is to make it an exponent. So what I'm saying is, stick this in your calculator: 15625 raised to the 1/6 power. And you don't have to put it. You don't have to necessarily write this part. You don't have to use the fractional notation that's in the calculator. You can just say 1 divided by 6, and it'll work just fine. So I'm going to do that really quick. 15,625 raised to the 1/6, and you just see if it comes. And it does come out. It comes out to a 5. So if you ever want to know what the 5 to the 6th power is, it's 15,625. But there you go. All of that reduces down to 5. Okay. Number 7, same idea, but we're dividing. If I were you, pause it. See if you can do this real quick. All right? And for those of you who are a little less, what you call it? Trisome? Anyways, whatever. We're going to do, just put them together. 343 divided by 7. Because we have the same number out front, which remember, if there's no number, it's a 2, because it's a square root. And 343 divided by 7, I believe, is 49. Yep, it's 49. So you get the square root of 49, which you should know the square root of 49 by now is 7. If you don't know that one by now, shame on you. You haven't been paying attention. You should probably learn that one. Because 7 squared is 49. Therefore, the square root of 49 is 7. Okay? If you want to try number 8, please pause and try number 8. But let's do it real fast. They're all to the 3rd power, right? Every last one of them. So let's write them as the 3rd root of 25 times 10 divided by 2. Which 25 times 10 is 250. Divided by 10 is 125. That's the 3rd root. And the 3rd root of 125 is 5. Because 5 times 5 times 5 is 125. All right. And if you don't have your 3rd powers, remember, I would learn your 3rd powers, your powers of 3 up through at least 5. So like 2 to the 3rd, well, that's 8. 3 to the 3rd, that's 27. 4 to the 3rd, that's 64. And 5 to the 3rd is 125. And the reason I would memorize those is simply because they come up often enough that it's good to just recognize, oh, well, if I want the cube root of 64, that's 4. That sort of thing. All right? Anyways, how about it?